Here's problem 3044. A long solenoid, little n is equal to 1200 turns per meter, radius equal to 2 centimeters, has a current of 0.3 amps in its winding. A long wire carrying a current of 20 amps is parallel to and 1 centimeter from the axis of the solenoid. What is the magnitude of the resulting magnetic field at a point on the axis of the solenoid? Alright, so let's try to visualize what we have here. We have a solenoid, and we have our axis here, and along this axis we have a magnetic field, which would be the magnetic field of the solenoid. We also have a wire that is 1 centimeter away, carrying a current equal to 20 amps. And because of this current of 20 amps, there's a magnetic field going around this wire. And at the point where it intersects the axis, it would be perpendicular to the magnetic field of the solenoid. In other words, this would be a transverse field to the axis of the solenoid. Hence, we will have a right angle right here, and that magnetic field, just call it B. It's going around like this according to the right hand rule. So we need to add these two magnetic fields, and they're going to be perpendicular to each other on the axis. Alright, the magnetic field due to the solenoid is mu naught little n times the current of the solenoid. That's going to be 4 pi times 10 to the minus 7 times the number of turns per meter, which is 1200, times the current of the solenoid, which is 0.3 amps. So this gives us a magnetic field of what? .52 times 10 to the minus 4. Tesla. And its direction would be, as I've drawn it, to the right, like this. Now we want to find the magnetic field due to the wire. The magnetic field due to the wire is mu naught I over 2 pi r. So that is 4 pi times 10 to the minus 7 for mu naught. The current is 20 amps over 2 pi, and we are 1 centimeter away. So what does that give us? Let's see. Four times 10 to the minus 4 Tesla. Alright, so at the axis, we've got these two fields. We have the magnetic field of the solenoid, which is 4.52 times 10 to the minus 4. And then we have the magnetic field of the wire, which is perpendicular to that, and that is 4.0 times 10 to the minus 4. So our net magnetic field, which will be this one, we'll have to use a Pythagorean theorem to figure out what that is. So the magnitude of that field is going to be equal to 4.52 squared plus 4 squared square root times 10 to the minus 4. So that is equal to what? .04 times 10 to the minus 4 Tesla. And this field will be going at the angle like that. I guess we could figure out what that angle is. It would be the inverse tangent of 4 divided by 4.52. But the main thing is we have a magnetic field of 6.04 times 10 to the minus 4 Tesla.